Hello, everyone. I am Grisha Skobelev, the host of Book Club Between Breakers. And with me today, it's my co-host, Nikolai Golov. Hi, Koля. And
Hi, hello everybody.
our club has a today celebration. Recently, we read the beautiful book, Distribution System. And today we make an interview with author, Maarten van Steen. Martin, hi, we are very glad to see you. Please tell us a little more about yourself.
Well, first, let me thank you for the invitation. I'm really looking forward to this interview or discussion. I hope it's actually going to be. Just a brief introduction. Well, okay, I'm indeed co-author of the book Distributed Systems. I think I'm actually the main author. I think Andy Tanenbaum, well, I know for sure that he agrees with that. In my daily life, I'm a professor of computer science at the University of Twente. I also worked for a very long time at a university at Amsterdam, the VU University. Not surprisingly, my expertise is in large-scale distributed systems. I immediately have to say that at the moment I lead more the life of a research manager than a scientist and an author. I suspect that approximately 75% of my time I actually spend on solving other people's problems. Let me put it that way, very much related to research. The fun part of my job is that at the University of Twente, I'm scientific director of a institute that crosses all the groups that have anything to do with digitalization. So again, I consider myself a student because I learned so much about what other people are doing in this field of digitalization. And I can tell you, it is a lot. So that just as a brief intro.
Fantastic. Thank you. Thank you. You're very inspired person and the good example for others. We follow up with a few more questions to let our audience get to know better you, what your favorite programming language and why.
Yeah, I actually had to think about this. Well, I must say it used to be C for the very simple reason that, I'm really a computer systems guy and I like programming close to the hardware. And C makes you very much aware of what's going on in the machinery under the programming language. But in the last years, I must say, I have grown pretty fond of Python because it allows me to express in a very concise way, rather often intricate aspects of programming, actually. So, and I really love all the libraries and also from a systems perspective, you can't go down that deep. But you can express lots of things that have to do with concurrency, with distribution, with whatnot. And there are so many libraries available that allows you to concentrate more on the problem than on, the language itself. And that's something that I can appreciate in Python. It took me a while to appreciate Python, I must confess.
Okay, thank you for sharing. And the last one, small talk questions. What inspired you to work in IT industry?
Yeah, that's a good one. I'm a trained applied mathematician. I'm not proficient in math anymore, but this is really, really long ago. And it was by pure coincidence that I actually bumped into computer science. What is important to realize is I'm an engineer. That means that I like to fix stuff, and I always, well, before you can fix stuff, you often break it. What I really liked when I made this step to computer science was this systems engineering, as I call it. And I immediately got fascinated by operating systems and whatnot. And how can you actually put the hardware to work for, the things that you have in mind, which for me initially was a really big challenge. And to be honest, it still is. And that's actually my main inspiration. It's really complex to get things working. And I find that attractive. So there's no obvious solution beforehand.
Cool. Thank you for sharing. We can go to main content interview. And first of all, questions about the book. How did you start collaboration with Andrew Tanenbaum about this book?
Yeah, that's an interesting one. So years ago, Andy actually recruited me in his group, Computer Systems in Amsterdam. And I immediately took over the course on what was then called distributed operating systems. And I'll be honest, after 1 or 2 years lecturing from the distributed operating systems book from Andy, I told him I don't like the book. And I said, "Oh, what's going on?" And he said, basically, it was about that there were so many details missing. And I really had the strong feeling that it shouldn't be about operating systems. It should be about distributed systems. So not even distributed operating systems. And Andy is a really, he's extremely good actually. So he recognized this and he said, well, my field is operating systems. Your field is distributed systems. If you're so keen on saying that my book is not good enough for distributed systems, maybe we should write a new one. And it's going to be your job mainly. Okay. So suddenly I find myself being co-author of a distributed systems book. And that actually got the whole thing going. And I have learned so much from Andy on how to write a book. And it just turned out to be a lot of fun. And this was, what is it? More than 20 years ago, actually. And I can tell you, I have written a couple of books before that. But I think at least when we started the distributed systems book series, I could say that every edition was written only once. So my canonical example was my first book, and I tell everybody I wrote that thing 3 times before I got it a bit right. And doing it right the first time is really the difficult part, and Andy taught me how to do that. So I'm still very thankful for him about that.
Yeah, it sounds like a cool story, and we also all love the book, and it is why we here all.
Mm-hmm. Yeah, nice. Yeah, well, thank you for your kind words. Actually, we'll probably get to a couple of things that are not so good in the book later on in the interview. But for now, I'll just say that it's an excellent book, and it's blah blah blah. That we'll get to the nasty stuff later on.
Okay, so let me go to my part. First, about contacts, let me also introduce myself. I'm Golf Nikolai. I'm head of data engineering in ManyChat, and I do research papers about big data modeling, data model, like all the stuff, data analytics. And also, I'm also a lecturer in university, mostly in the university here in Barcelona. But I also have lectures in Bangkok. So I very also very interested in working with students, working delivering them data. Like I have courses about databases, all type of modern databases. And that's why I'm very interested, because I have read introduction to all versions of your book. And based on your experience, so am I right that when you have created this book, like starting from the second version, you was targeted in it on students? Because we are we are a book club. We are a book club of backend developers. But what do you think? Students or backend developers? For whom?
Yeah, so I really like that question. It's primarily for students, and software development itself is a completely field in its own, and for writing software. And the reason why I say that, well, of course, it's also intended to be useful for software developers. But for me, distributed systems is not about software development. So you cannot build a distributed system if you're really good at software development only. Yeah, that may require some thinking. I just mentioned systems engineering. And, when you build an operating system, for example, if you miss in the core of an operating system just a single line of code, your operating system will break. That is not a software development problem. It's a systems thinking problem. So you need to think really hard about the algorithms, about what kind of communication paradigm you're going to be using. Many of these things that allow you to pull all these different aspects of a system together. And yes, what you will do in the end is program all these things, but without having a very clear picture of how all these things tie together, you cannot develop a distributed system. You cannot develop an operating system. So the programming language that you use should be your tool and not your problem. Your problem is the system, and you have to be proficient in the tool. And that makes it different from a software development project, from my perspective. So it's systems thinking versus software thinking.
Yes, and it gives a very tight connection to other topics which were also discussed in our book club previously, with architecture and all the stuff. And by the way, it is also very important, because when I started my course, I started teaching databases, but I understood that it is useless to describe database without describing a system which will use this database. So basically, we also switch to system design.
That's the systems thinking. Yes. Yeah.
Yes. And because of it, I want to switch to the, we have a set of questions which are based on the evolution of version, because we see that those versions of your book, the editions, they're very different. There is a huge changes between them.
Yeah.
So so am I right that first change between first edition and second, it was your idea which you introduced to Tanenbaum, that from operating system to system design? Am I right?
Yeah. So that's I like this one. So one of the toughest thing about even for the first edition was to think. So my definition of my description of distributed systems is that when I tell students this, is that it's a system where you push over here and it starts hurting over there. And what you need to do in the end is to try to understand what the relationship is between essentially, fixing something over here and seeing a completely weird thing happening somewhere else in the system. And the thing is that everything in a distributed system is tied together. So, for example, there's no such thing as a security module. And there's no such thing as, well, to a certain extent, a communication module. All of these things are everywhere. So I discussed at length also with Andy, how do we present distributed systems in a more or less structured way? And this is how we came to these perspectives that you have. So, we now have this introduction and we have architectures. I think those two things are really just kind of setting the scene. So I agree with you. Architecture is very important because it gives the student at least an overview of how things can be tied together. But after that, it's really about, okay, let's just look at processes, because processes are one of the most important things in distributed systems. How do they collaborate? How can you organize them? Blah blah blah. Then let's just look at communication. Let's just look at coordination. Let's look at some common algorithms. Let's look at fault tolerance in distributed systems. Let's look at security in distributed systems. And what you then hope is that by the end, people have seen these perspectives and that they then have the complete picture. And in every chapter, you see that you can, for example, if you discuss security, you cannot understand security without understanding communication. And you cannot understand communication without understanding security. But you have to you have to treat them differently, and at the same time just say, let's just look at this system from this view, and the view would then be, for example, security, and then what do you see? And that was kind of the biggest challenge that we had, and I'm often still struggling with this, and how to present this. So there was one big change, and I think it was from the second to the third. In the second edition, we still had these example systems at the end of the book, right? Something like 4 chapters on web-based and object-based and whatnot. And I found that difficult.
I suppose that it was called paradigms.
Yeah. And I found that a bit difficult because, for example, if you would look at distributed file systems, it would seem like a distributed system could be like something like a distributed file system, which is kind of true, but that's not the whole story. And not all of these paradigms had all of the elements that we discussed from the perspectives point of view. So at a certain point, I decided, let's just take examples of types of distributed systems, like distributed file systems, and discuss them in the right chapter where you see very specific things pop up in that chapter. So I'm not quite sure where we discuss distributed file systems. There must also be with communication. I'm quite certain, and I think we also discuss it also with fault tolerance. I've written the book, but I don't have it. I don't know it by heart, so apologizes for that. To then use these paradigms more of an illustration in practice of the things that we're explaining when it comes to the principles. How is this organized in NFS, for example? Or when you think about web-based systems, how is replication and caching organized in a content delivery network, which is basically a web-based system? And then suddenly you have these paradigms put into the right perspective. And I like the idea of the content delivery network because you can focus then on distribution transparency. How is that realized? How is it implemented under the hood without you really noticing? So that was one of the reasons why what also is important to realize is this is a really fast forwarding moving field, right? It's I'm amazed by the speed that we do things. So the third edition was from 2017, and I told my university, well, I always have too many holidays left, so I'll just pile them up, and then in 2022 I'm going to have this kind of part-time sabbatical. By the way, I will not advise anybody to do this because basically you have to work like a dog, more than usual. But I thought, well, if I spend a year on this, I can catch up with a lot of new developments, and also importantly, spend time on the chapters that I was not satisfied about. I was particularly not satisfied about the security chapter. I'm not really a security expert, and I really wanted to fix that chapter. But things are moving so fast in this field that I think that, updating the book every 5 or 6 years really makes a lot of sense. And I do want to have some of this old stuff in there as well, because it's really there. That we use stuff that was invented 20 years ago, and it survived everything. That makes it really important. I'm not quite sure if I answered your question, but
it's like great illustration, because of course you understand this evolution, but for our listeners, like second edition have the same 9 chapters at the beginning, with the last one about fault tolerance, but afterwards there was, I suppose, 5 or 7 about paradigms, about big examples of sample systems, and they were excluded after they were excluded starting from version 2.
2 or 3, yes, something like that. Yeah. It's okay. Yeah.
And also, I was very impressed to know that, for example, third edition, there was a lot of example in Python and Redis. And by the way, I also like all practice projects of my students are also done using the same tools. I also like them.
Koля very like Redis, yeah.
Like everybody likes Redis.
I hope that you discovered that the implementation that I used for the third edition was far from optimal, and I think it was even incorrect at various points. That has been corrected for the fourth edition. I was looking at my code and saying, this is not correct. This is not good. So, but anyway.
So, question is, why have you decided to add this practice, and like how it evolved to fourth edition?
Yeah. Okay. What I noticed. Well, actually, I'll give you a very concrete example where I think it really makes sense to give coding examples. I got stuck on explaining remote procedure calls in the following sense, that there is a lot of stuff going on under the hood. And at a certain point, I wanted to explain to students how you can completely mimic the semantics of a remote procedure call by just doing a local procedure call. So there's something really nasty going on, right? Everybody can say, yeah, you do a marshalling and then, you send it off to the server and you get an answer back and whatnot. That may be true, but there's this small thing where you have your client waiting for an incoming message, and then it needs to do some really small thing to pretend to the application that is calling it that it really is returning results as if they came from the stack. And I thought by myself, let's just make that visible in code. Another example, which I thought was relevant, that people were at a certain point talking about remote references. What's a remote reference? Well, in essence, it's Java code that you just ship to the other server, right? It has everything there. So you suddenly have a stub that you use to move to a server, but the stub it's just code, can be interpreted so the server knows what to do. And you can try to explain this in words, or you can show it by example. And these are things where I really was motivated. Let's just show it by example. Another one, which was an eye-opener for me, is I really have trouble understanding things like partial synchrony. So we have asynchronous systems, we have synchronous systems, we have partial synchronous systems. And my interpretation, it was that so the problem there is, you have to use timers, and you have to take it from there. And you can use timers when you're in a system where that is fully synchronous. But we know that our normal systems are really asynchronous. So we try to make them partially synchronous. And what you do is, and I think I illustrated this in the two-phase commit protocol, where you decide, yes, the server is down. And then you start writing your code, but the problem is you never know for sure. Your timer said it's down, but you don't know for sure. So what you then see in the code is that you say, I'm assuming the server is down, but I may be wrong. So what you see over there is that you can still expect messages that basically say, well, no, the server wasn't down. It was just really late. And this is how you then implement partial synchrony, because if you get this right message, this correct message in, you can go back to your original mode saying, oh, no, I was wrong. The server wasn't down. It was up and running. So now I can just proceed according to the normal protocol. So then I give a very concrete example how you implement partial synchrony, what partial synchrony means in a concrete protocol. Maybe you made the wrong assumption. Okay, deal with it. So this is where you see that an example, I hope, will give the student insight, this is how it works in practice. And then I don't have to use the words to explain it. They can just look at the code. And that inspired me to, at a certain point, start throwing in much more coding examples. And what I really needed was to have something like Radius, where I can have conditional weights without, being completely worried about all the wake-up functions and whatnot, because Radius says, well, I will just start this process again when I see that the following values are available. So it's a great tool to actually give me a very simple way for an advanced communication library. So that's the reason why I actually used it.
It's really cool when you read the book and find some insight. Yeah, it's fantastic. I have a couple of questions about third edition, about your thinking. Which, if you have 1 hour, which chapter do you prefer read and why?
Yeah, that's well, an hour is not going to be good enough for any chapter, I think, because I think if you want to read the book, just read without even study, you would consume a lot of time. There are 2 chapters I'm kind of fond of, and that's the fault tolerance and the security chapter. The reason why I like the fault tolerance chapter is that, there are a couple of reasons. First of all, fault tolerance is at the heart of distributed systems. So you need to spend a lot of time on that. And the fault tolerance chapter is, I think, one of the most challenging chapters for me to write, because it is just difficult. It's really difficult to build a fault tolerant system. And I think the way that I explain Paxos is very insightful. I'm not quite sure whether you know this, but I never understood Paxos. And what happened was, a colleague of mine, Hein Meling, he's at Stavanger University at Norway. He really knows a lot about Paxos. So I asked Hein, can you explain to me how Paxos works? He's sure. Come on over and I'll go through the whole protocol and whatnot. And he started with a bunch of slides. And I said, why this? Why that? And after an hour, he said, I don't think this is going to work. And so he stopped explaining to me how Paxos worked using the standard explanations, because I just didn't get it. And what we did is we locked ourselves up and we pretended to be Leslie Lamport. But of course, we're not Leslie Lamport, and I'm never going to be so pretentious that I think that I can have the level of Leslie Lamport. But anyway, so what we did was say, if we were Leslie Lamport, and we ask ourselves, how do we build a fault-tolerant server? Well, the first thing that you do is you add one server, right? And we tried to build up the whole story to the point that, at least for the book, we had to add this third server, okay? Because you have to have, under crash failures, you have to make some assumptions. Okay, crash failure semantics. And we came up with a story that explained to us how Leslie may have thought when gradually deriving the Paxos protocol. And after 2 days, we had a story, and he could really explain this well. And I finally think I understood Paxos. Now, why am I giving this example is that what's important for any author is that if you need to explain something, you really, really have to understand what you're talking about. Paxos is one of those examples where for a very, very long time, I would not have said I feel completely confident in understanding, in saying that I understand this protocol. Now I feel much more confident and I can explain it much better to the students. And that's what I like about this chapter on fault tolerance. And this is also why I think I can now also explain Raft and where it came from. Raft is really interesting because Paxos is really an intricate protocol, and many people are worried about, have we implemented it correctly? And John Oosterhout had exactly this problem, and this is how they came up with Raft. And so there are so many of these fun things in that chapter because it's not simple, and you have to explain it well. And I hope that that is also reflected a bit for the students in this chapter, like, oh, wait a minute, there's a lot of stuff going on under the hood, and the authors really spent at least a lot of effort in doing their best to try to explain this. The same holds for the security chapter. When I talk to my security colleagues, they have a different way of thinking. I don't have that thinking. And I was looking for the security chapter, especially for the 4th edition. Can I explain it in such a way that I feel confident in what I'm explaining? If you go through this chapter, there are many things that I hope you'll notice that, yeah, he probably understood this. But I'll tell you, I'm not too confident about multi-party computation, which is a really difficult thing. And I think if I go for the 5th edition, I'll probably spend more time there and also talking to colleagues, perhaps we do the same thing as with Paxis. Tell me how this really works. And once I have that, then I think I can probably better explain how multi-party computation works, which I think is an important concept for distributed systems. So, yeah, those 2 chapters, they're tough chapters, but I think they're fun chapters. There's a lot of information in both of them, though.
Cool. Yeah, it's very nice when you try to understand how Raft or other complex system work, and it's make you better like a software engineer. One more questions. It's more off top. Recently, you say what this book for more student, but maybe you can recommend some handbook for developers, what all developers need to read, or maybe it's a few books.
Well, for developers, I've thought about this, so I find that a bit difficult. Maybe I should. Well, I'll ask you a question. What, from your perspective, is the most difficult thing for developers when they think about distributed systems?
Consistency, data consistency. Yeah, it's the hardest point.
Yeah, that is really a tough one. What is nasty about? Okay, actually, I don't think people should be worried about data consistency, provided we do the following. I personally believe by now that most people can understand only 2 types of consistency. That's the sequential consistency, and sequential consistency is exactly what you do when you do parallel programming, right? You know that if you do not put locks in the right places, you'll get chaos because too many processes are at the same time share data. But the interesting thing is not that chaos. The thing is, when you see a result, you can explain for yourself, yes, I understand this result. This is not what I wanted, but I can understand why this value shows up in this variable. And yes, I know how to protect this. If I just put the locks in the right way, then I'll get what I want. So that's sequential consistency. And you see this everywhere. Transactions, whatnot, they are all sequential consistency. And I think most developers understand that. So my first advice is, if you need something like consistency, go for sequential consistency. And this may also explain to you why I love centralized solutions. I love solutions with a central component, a coordinator, because if anything goes wrong, you know exactly where to go to. Do they scale? They scale like hell. I can tell you that. Because then what you start doing is you start partitioning data and whatnot. You know, my famous example is the root in the DNS system. My God, that's a beautiful decentralized and distributed system. And yes, it's largely decentralized, but we know how it works. And the second type of consistency that I think most of us understand is eventually consistency. We all understand that if you have a kind of one writer model, which means that only one process somewhere writes something, and you first let that right be disseminated through the system, then everybody understands that eventually all the replicas will have the same value. And this is exactly, for example, what happens in proof of work systems and blockchains. You know, if you start thinking in terms of, I need a leader, a single one, who can then append a block to the blockchain, then suddenly everybody will understand, oh, yeah, sure, then it works. And then if you have two concurrent leaders, okay, let's just fix this in the sense that the one who discovers a process discovered that one branch is shorter, just ignore the shorter branch and go for the longer one. So these two models, I think, are the models that most people understand. And this is the reason why I recommend to developers of distributed systems, whatever type of distributed system, go for only those two models. All the rest are optimizations that are extremely difficult to understand. And
Thank you.
even if you take a look at conflict-free replicated data types, which is, you know, coming in on vogue, I should say. And I think Mark Shapiro really did really good work in that sense. He gave this a lot of thinking. But what you really do there is provide application-specific protocols to solve conflicts. And in many cases, you know, if you think of that application, can I afford that a last writer wins? Yes, then you do that because, you know, apparently the application can handle it. Or if I cannot, if I really have conflicts, well, just throw it up into the air, and then at the application level, meaning the user, should have to solve this. You know, and then you have these application-specific protocols in there that should work as well.
Yeah, CRDT, it's interesting concept, but maybe it's not ready for production. It's
Well, people claim that it's already being used.
We have CRDT systems in production. Some of them, they are quite complex. There are a few of them, but
yeah, they are. Well, by the way, talking about these things, one thing that I really encourage my students to do, and I hope you do this with your students as well, I think we're reading too many blogs in the following sense. I want to compliment many of these bloggers because I think they're doing a fantastic job in trying to explain really intricate things, and they simplify matters. What I don't like is that they often present their simplification as the truth. And, you know, I don't know if you know this, but take a look at the discussion of virtual machines versus containers, and you go to the blogs on containers, well, the first thing you read, oh, they scale, they're much more efficient, you know, as if it's the holy war against virtual machines. But if you understand how containers work and you understand how virtual machines work, then suddenly you will see, wait a minute, those claims are not right. There's much more under the hood. And then suddenly, if you start to do performance measurements of virtual machines versus containers, wait a minute, the difference isn't that big. They become big when you take a look at, for example, disk I/O. But we can explain why that's the case with virtual machines, because they really have to go through another guest operating system and then through the host operating system. Oh, that, because we're talking about privileged instruction execution, that may cause delays. Okay, well, containers have less of an issue there. And I really hope that, you know, a book like mine can contribute to stimulate students go beyond the blogs. Try to verify what is written in that blog, if that is really true. You know, one of these other statements like centralized solutions are bad. No, they're extremely good. And they scale like hell. And, you know, but not all of them. Figure out the details and then say under which conditions centralized solutions are good or bad. We don't do that enough, I think.
Yeah, it's like all architecture life say, depend it. Yeah.
Yes, and by the way, we even discussed one books previously, which is pretty close to what you have mentioned, the blog style of like book, which helps people to prepare for assistive design interview. Very brief, very unsophisticated, undetailed study of each topic, which helps you to pass the interview, but gives you zero understanding of how it shall works. So. Not super idea. And by the way, I want to switch to last topic about the future. Because, evolution of your book is really great. It shows how these topics evolved. Some topics was introduced, some topics was removed. For example, one of the last discussion which we had, it was about the blockchain, which you also mentioned. We have a real blockchain developers of real wallets. We have great discussion of how this technology works, of like so many algorithms which together can give you this great capabilities, but all of them answered no practical usage except for digital money. I was thinking that I will argue with them, but all of them said no practical usage, inefficient, other tools are better. So what do you think? What technologies, what approaches shall be added to your book later, and which of them shall be removed? Where are we going in terms of technologies?
Yeah, that's a good one. For first, I fully agree with you. And following also, I don't like blockchain. I love the technology, but I don't like blockchains for the very simple reason: what was the problem that needed to be solved? Having said that, I definitely wanted to include something on blockchains in the book from a very neutral position, because I don't think it's fair not to discuss them if so many people are working on them. And then what I try to do is to bring this into perspective. Will blockchain show up in the 5th edition? I don't know. Maybe as a side remark. I really don't know. If you ask me, what are we heading toward? Well, this is, I really like that question, by the way. There are a couple of things that I want to mention. One, I already mentioned about the blogs. What I really hope is that people will go deeper into stuff and then understand what these bloggers are doing. And let me not dismiss their quality, because making things simple is really important and difficult. But don't make it too simple. What I often think is that in the distributed systems community, we're focusing too much on what I call something like an inside-out view. I would recommend to everyone to read the book by the Google folks, which is called The Data Center as a Computer. It's free out there on the web. And what I like about this book is their holistic view. You know, if you zoom out a bit, they could have also written a book on chip design, where cooling is in place, where the layout is in place, and they just move this up from these very lower layers to the data center. And one of their statements in that book is saying, we are still talking about, I think, networked data centers or network computers, because this is how the developers think about these Google data centers, right? You have a data center over there and a data center, blah, blah, blah. What they say also is that the moment that the connections between these data centers are much better, and they will become much better, and the software to make use of the connectivity between the data centers is going to help developers, then most of them will think of the Google data centers as one big data center. Now, I really like this idea, because if you start thinking about this, what does that mean for our discussions on, for example, edge computing? Is an edge nothing else as just another component in this huge worldwide computer system? I think so. And if you start thinking about that, then things like locality come into a different perspective. And things like orchestration I personally think will vanish. Do you remember the discussions on web caches we had, 15, 20 years ago, something like that? Oh, web caches, no, blah, blah, blah. We're not talking about web caches anymore. They are there as an element in the network, and they're doing their job. And that's it. And I would not be surprised that edge computing will be there, but not for the reasons that we often now have edge computing. It will be just convenient or sometimes necessary because there are occasions where we cannot beat Mother Nature. There will be latencies. So for augmented reality, you probably want to do a lot of local processing because you can't afford, let's say, a 300 millisecond delay because it will not be good for your user experience. If people say we're using edge computing because of privacy, I tell them you have to rethink what privacy really means, because privacy is not something that can be tied to locality. Maybe now, but certainly not in the future. So this is one thing that I really hope that we will be developing a more holistic approach towards distributed systems. And then from there, rethink things like edge computing, all these things that are very much this inside out view. What I also hope, and I think this is going to happen, is that security is going to be a first-class citizen of distributed systems. We cannot discuss distributed systems anymore and then plug in security as an afterthought. I have seriously considered to put the security chapter as one of the first chapters in the book. Colleagues of mine strongly advised against that. But I will see what the developments are, let's say in a couple of years from now, to make me move security into the first parts of the book, to make this really a first-class citizen in anything that you design. So if you then start talking about communication, the first thing that you do is think about secure communication. What does that mean for the communication protocol you develop? So that's at least for the, I would say, almost near future. You probably want to ask something about AI and distributed systems.
Yes, popular topic, but I'm not sure how many time we have, because about all the story. For example, from the point of time of databases, I know that many databases was broken by the issues of privacy of GDPR, CPA, part of my responsibility now. And also currently one of the topic of my research is serverless systems, serverless databases for big data, where I cannot say, are they distributed? They definitely are, but there are no parts. They are working together and we're working great.
Yeah.
And I simply don't know what algorithm of consensus they're using. Externally, they are like, they're just working.
I think, unfortunately, our time is over. It's fantastic discussion, and as old tradition, we can make a shared photo. I think, Roman, we don't have a time for questions, unfortunately. But all who with our Zoom, we can show the coverage of the book and take a shared picture. You can start.
Everyone, the book is out there to grab for everyone for free. So this is
of course.
This is also a design principle. Education should be there for everyone. So
fantastic. And it's so cool. We very happy read this book and very a lot of fun.
You have it electronically, but then let me also show that there are actually
paper version. Wow, fantastic.
Some of us even have paper version, I suppose. One or two.
Martin, you can take a picture with paper version, and
I'm trying to do it like this, and then
Fantastic.
Let's
Yeah.
go.
Cool. I make a picture. Yeah, Martin, one more time, we want to say a huge thanks for the book, for your book. Yeah, it's really cool. And also, we very glad to have communicate and discuss today with you. It's fantastic. We glad to you. We have a nice day. Have a very
So
awesome.
let me thank you as well. It was a great honor to be interviewed by you. I really appreciate your work, and I like the idea that there are a bunch of these geeks out there who do this stuff and actually try to communicate this to the world. So a big thank you also from my side, and it was more than just a pleasure. So again, also from my side, a big thank you. Okay?
Yeah.
And
Thank
keep
you.
on with the good work, because what you're doing is something I think we need a lot more. Very good. Okay?
Thank you.
Okay, let's stay in touch.
Yeah.
Bye-bye.
Yeah.
Bye.
Bye. Bye.